So today we'll be doing trig triangles or trigonometry in triangles or trig rules. Don't forget to subscribe to the channel. Okay, there are rules that we're going to talk about here. The first one is area rule. And we have a sine rule. Then lastly, we have a cosine rule. We do not have a tangent rule. So it's area rule, sine rule, and cosine rule. So it's very important for you to know the properties of area rule and the properties of sine rule, as well as the properties of cosine rule. So if you're in grade 11 and grade 12, this is your stuff. You understand this topic better than me. Okay. So you know the basics of trigonometry is that we have what is known as a right-angled triangle. So this is a right-angled triangle because of the 90 degrees here. So this is the triangle whereby we can be able to use what the theorem of Pythagoras on it, right? And we can be able to use this triangle. We can be able to use trig ratios or trigonometric ratios, sine, cosine, and tangent trig ratio, as well as the what are these reciprocals, and we can be able to calculate the area of this triangle using that formula on your screen. So the name of this triangle is what? Right-angled triangle. It has the longest side, we use the hypotenuse, opposite and adjacent. That's what you know from grade 1. You were taught that by your mathematician back there in primary school. Okay, so but they can give you a triangle that is a non-right angle triangle. So a non-right angle triangle is a triangle that is not a right angled triangle, as it says, non-right angle triangle. So this is a non-right angle triangle. Why? Because it doesn't have what? A 90-degree angle. I hope that makes sense. This is a triangle ABC. It's a non-right angle triangle, meaning we cannot use the theorem of Pythagoras here. We cannot use trig ratios, even the area rule, that the one that says half base times height. We can't use it, but there are means that we can actually apply on this triangle ABC, so that we can be able to use trig ratios, theorem of Pythagoras, as well as the area formula. So we'll actually start by explaining the triangle and telling you the properties of the rules. Then after that, we are going to prove the rules, but it's very vital for you to know it. It's essential that you know this stuff. And another thing that you must know, please do not forget to subscribe to the channel, like the video, to share it, and to comment on the comment section. Let me just erase what's appearing here. I was doing probability, so I forgot to erase the Venn diagrams. If you didn't watch it, make sure that you go there and watch that video. You really need it. Many learners they hate probability, but if you can go and watch that one here in our channel, you're going to like it. You're going to even smile. It will look like you ate Smarties. They call them Smarties or Smarties. I don't know. I don't have time for sweets. So we have triangle ABC. Now, as I'm circling these points here, these are angles. These are angles. Triangle ABC. So angle A and angle B and angle C. So the opposite side of angle C is AB. Then I'll put a small letter C. Then the opposite side of angle A is BC. I will put a small letter A at BC, wide line segment BC. then the opposite angle of B is AC. So these are angles. Then these ones, the small letters, are sizes or lengths. I hope that makes sense. Or sides. So it's very important. The vertices are angles, the sides are those small letters. I hope that it makes sense. The vertices are the corners. The singular name is vertex. Okay, let's try to explain the rules. So make sure that you write them down, pause the video. Now the sine rule can be used when given an angle and its opposite side together with another angle or side. Meaning you must be given an angle and its opposite side together with another angle or side in a triangle. So I'll try to explain this thing in a triangle. Let me just erase this one and draw a new one. Okay. This pen that I'm using right here, it is giving me problems. Let me just start it afresh. Okay. There we go. So this is our triangle. We have triangle A, B, and C. Now, for an example, let's say we have 25 here as our angle, and its opposite side is 11, which is AC, 11 centimeters, and the length of BC, for an example, we have 20 centimeters. Now, we can see now that the angle 25 here, or the sine rule, can be used when given an angle in its opposite side. We have the angle, which is 25, right? Then its opposite side is 11. Then we are given another side. That makes us to be able to use what? Sine rule. I hope it makes sense. That's very, very important. You must note that. Okay. Now, let's say we are given, I don't know why I erased that 25, the very same angle here and 11 centimeters. Then inside here we have, for an example, 31. So the angle here in each opposite side and another angle. That makes us to be able to do it, to use sine rule. So that's important. That's what you must know. We'll actually jump to the cos rule. I hope it makes sense, guys. So you can only use sine rule when you are given an angle in its opposite side together with another angle or side. Let's jump to the cosine rule then. It's on too. Okay, so cosine rule can be used when two sides and the included angle are given, or all three sides are given. So we have two properties here: two sides and included angle, or all sides in a triangle. So let's say we have 11 centimeters, we have 30 centimeters, and we have 21 centimeters. So the last or the second property says that all three sides are given. So since now we do have side AC, we do have side AC, and we do have A, B, and BC, we can use what? Cosine rule. I hope it makes sense. Then let's say we have side AB as 20 centimeters and we have side AC as 10 centimeters. Then we have 40 as angle A. So these two sides here, as the rule says, that can be used when two sides and the included angle are given. We have side AB and side AC together with what? The included angle. The included angle is the 40 there, meaning that this 40 is formed by 10 centimeter and 20 centimeters. Therefore, it is known as what? As an included angle. Therefore, we can use what? Cosine rule. I hope it makes sense. That's very, very important. Now, let's say we have another triangle here with 14 centimeters and 14 centimeters. Then we have an angle here. So we have two sides, but we don't have an included angle because the included angle must be between these two numbers, two sides, right? That 30 can be an included angle. We have 40 and 30, then the 30 inside. So since we have this 30, this is an included angle. Why? Because it's formed by 30 and the 40 the sides. Therefore, we can use what? Cosine rule by those reasons. Make sure that you pause the video, you write this thing down. So it's very important for you to memorize these properties or these notes. Very, very important. You will see when we actually start doing activities here to actually check our knowledge. So it can be used to calculate the area. So this one can be used to calculate the area when two sides and the included angle are known. So it's the first note for cosine rule, because we need two sides and the included angle. Then we can also use what? The area rule by having that note or that property. So let's say we are given 20 is the side of AB and 30 is the side of AC. Then inside here we have 15. So the 30 and the 20, they make the included angle 15. I hope it makes sense. Then that's when we can be able to use what? Area rule. Sometimes they can actually give you a triangle like this. Then what you must know is that when they give you these two sides, then the angle inside becomes what? An included angle. So this included angle is formed by 30 and 10. I hope that makes sense. Or they can actually draw it like this and put, let's say, this angle triangle ABC. We have 30 right here and we have 30 here. Then the angle that will be inside here, it becomes the included angle formed by 30 and 30. I hope that makes sense. The 20 becomes the included angle. So that's very, very important. You must know what an included angle is and how it is formed. Okay. Let's try to prove the rules and see if we're going to understand each other. And if you don't understand, start afresh the video, rewind the video and listen to it carefully. Alright, we have triangle A, B and triangle C. So they'll give you something like this, then they want you to prove the sine rule. So they'll give you a clean triangle like this, then they want you to prove what? A sine rule. So we're going to prove a sine rule right now. So what we're going to do first is that we know that this is B and this is small letter C, right? The opposite side of angle C. Hope that makes sense. Then what you must do, you must actually show what you must show us the perpendicular heights. You create yourself a perpendicular height and you put what? In 90-degree angle. Then these are perpendicular heights depicted by H. Then you know that even this side here, okay, so this side is what? Is a right angle triangle, and the other side is also a right angle triangle, the blue one that I'm actually highlighting here. So we have two right angled triangles. I hope that makes sense. And you know from grade 3 that if we have a perpendicular height, the other side is also 90-degree angle, right? Or it is also a right angle. Let's say we have a line segment AC, then we have B here. Then they give us, or they say that side AC or length AC is of 100 centimeters. Then AB is 70 centimeters. Then what is BC? BC, when we add it with AB, it must give us AC, meaning that for us to find BC, what we must do is that 100 minus 70, we're going to get the value of BC, which is 30. Therefore, 30 plus 70, they're going to give us what? AC as 100. So I hope that makes sense. You know this. Okay, now let's actually say that part is x. We let that part to become x. As you can see from the perpendicular height to b, we let that part to become x. This is what you do whenever you are given a triangle, then they want you to prove. Then we know that a minus x, it will be from the perpendicular height to c, it will be a minus x. You do this whenever you are asked to prove one of the rules. But now we're going to prove what? Sine rule. So we know that the value this side and this side right here, they're equal to BC, which is A. I hope that makes sense. We said let that side be x and A minus x equals A minus x. Then when we add these lengths, they must actually give us BC, which is A. So these x values are going to cancel out, then we are left with what? With A, which is the value of BC. I hope that makes sense. All right, let's continue. Now, since we indicated that we have this right angle triangle and this right angle triangle, so I'm going to actually determine, or I'm going to use the first triangle with the red pen or ink and look for sine B. Remember, sine B equal to opposite over hypotenuse, which is C. Then let's make H the subject of the formula. Then what we're going to do right now, we're going to cross multiply. So when you cross multiply, what's going to happen is we actually divide with one side, we can deal with fractions both sides. Then we cross multiply. Therefore, sine B times C, it will be C sine B equal to H. Now this becomes our first equation. So we're going to solve simultaneously. So then we are done with that triangle. Let's just use the other triangle. Sine C equal to opposite over hypotenuse. Then we make H the subject of the formula. Then we divide here by one side. We can do with fractions both sides. Then we cross multiply. Sine C times B, it will be B sine C equal to the H. Then it becomes our second equation. Then what we're going to do right now, we're going to equate the equations. Why? Because they are all equal to C. So equation 1 equals equation 2. Therefore, C sine, let me just adjust my screen. Sine C B equal to B sine C. Then going to divide both sides by C. Then after that, the answer that you're going to get after dividing both sides by C, you divide both sides by B. But you can actually divide both sides by BC, so that you'll actually have one process. I hope that makes sense. You can divide both sides by C, then the answer that you're going to get after dividing by C both sides, you're going to divide both sides by B. Or you can actually divide both sides by BC to have one process. Yeah, I know that what I said is a bit tricky, but listen to it again. So these ones are going to cancel out, and the B's here are going to cancel out. So we are left with what? With sine B as the angle over the side, which is B, small letter b, sine C over small letter c. So you are done proving the sine rule. I hope it makes sense. Or you can also say sine A over A to earn the same thing, but you can actually use two equations. It can be the sine B and the sine C, or the sine C and the sine A, the sine A and the sine B. So you are done proving. But what you must know, they will give you a triangle that is empty. You show us what the sides, you show us the perpendicular heights, and you start doing your thing. So what you know here is that here we can be actually be allowed to do this. Remember, it's sine B over sine, over b, sine c over sine b, sine c. So you can actually use what I wrote on the left right here, meaning b over sine c, b over sine b, c over sine c. So the same thing. So you are going to be given a triangle, then they want you to actually prove this using this triangle right here, an empty triangle. So you do what you show us perpendicular heights as well as the other sides that you are given, then you form your thing. I hope it makes sense. This is very, very important. It's 5 marks or 4 marks sometimes, so you better know it. Well, let me just show you how to do this. Okay, let me do it like this. Okay, let's actually prove the cosine rule. Let's do the cosine rule. So what you must know here, you must know how to prove, you must know how to when to use that rule. I hope it makes sense. I told you before we do the proving about the rules, okay, or about the properties. So you'll be given a triangle like this, an empty triangle. Then you must show all of the perpendicular heights, the sides, and everything. Then you start proving. Okay, now let me give you a clue here, or a hint. Now, for when you're asked to prove the sine rule, you use trig ratios, as I was actually doing. Now, when you're asked to prove the cosine rule, you use the theorem of Pythagoras. So that's the hint. You must remember this. When we preach at church, we say this is a mystery. It's something that you must know. So we have two triangles here, or two right angles, angled triangles. By the way, I am a child of God. I'm a Christian. I'm born again. Jesus Christ is my Lord. He's the one who gave me this knowledge to teach these things, to know mathematics, to teach mathematics. So let's say we have c squared equals h squared plus x squared. Then we're going to say c squared minus x squared. Then we make h the subject of the formula. Then that becomes what? The first equation. Then we're going to use the second equation, the right angle triangle. So whatever that we're doing, we're using this triangle. Right now we're going to use the other triangle, this one right here, to make equation 2. So what you're going to do, theorem of Pythagoras, b squared equals h squared plus into a minus x squared. Then let's make h the subject of the formula. So b squared minus into a minus x close bracket squared equals h squared. This is our second equation. Then what you're going to do right now, you're going to equate the equations. Why? Because they are both equal to h. Therefore, what you're going to do right now, we're going to say c squared minus x squared equal to b squared minus a into a minus x close bracket squared. Then let's actually eliminate the brackets. We don't want brackets here. So b squared minus, remember we must actually double the brackets. Then we do the FOIL method to get rid of the brackets. Minus into, we actually do the FOIL to be a squared. A times negative x, it will be negative ax plus x squared, right? Then you close the bracket. Then let's eliminate the brackets. Therefore, we're going to have c squared minus x squared equal to b squared minus open bracket a squared minus 2ax plus x squared. Let's try to eliminate the bracket by distributing the negative into the brackets, b squared minus a squared plus 2ax minus x squared. Therefore, what we're going to do right now, we're going to actually transpose everything to the left except the b. So c squared minus x squared plus ax squared, plus x squared minus 2ax plus x squared equal to b squared. Therefore, the x squared, the 2x squared are going to cancel out. Why? Because they are the same but with different signs. I hope you see that. Therefore, c squared plus a squared minus 2ax equal to b squared. This is what we have in right now, right? Now, let's go to our triangle to actually determine this x in terms of a triangle. So this is what we're going to do. We're going to actually say you're going to use this triangle that I'm highlighting right here. It's triangle AB. We're going to determine the value of x, so we can substitute it there. So cos b equal to x over c. Then let's make x the subject of the formula by cross multiplying to be c cos b equals x, meaning that where there's x, we're going to substitute that c cos b. Therefore, c squared plus a squared minus 2a. Then where there's x, we substitute this thing. It will be c cos b equals b squared. Now you are done proving the cosine rule. So they will give you a triangle that's lean. You have to make sure that you show us the perpendicular heights and all the lengths. I hope that makes sense. So it's very, very important. Please try to understand this. If you didn't understand it, make sure that you rewind the video and you try to understand it, because you're going to actually come across this thing in a question paper or in an exam. So it's very important for you to know it. We will see when you start doing questions from past question papers, but for now, just make sure that you understand this. This is stage 1. In order for you to understand stage 2, you must understand this. So I'll show you an easiest way of how to determine the rules. Okay, now let's say we are given ABC. Then you know that these two angles, they form A, meaning A becomes the included angle, right? Therefore, what we're going to do now, let's write the cosine rule using these two. So, and these B and A, they are also included angle. They form the included angle C. They're just sides. Therefore, we're going to use ACB, those sides that forms angle A. That form angle A. Alright, so it will be A squared equal to the opposite of angle A's side A equals B squared plus C squared. Now these angles, they form the included angle. B squared plus C squared minus BC cos the included angle that is formed by B and C, which is A. I'm not sure if you understand this. I didn't actually hear myself here, but what I said is correct. I think we'll actually do the second one. What is the opposite side of angle C? It's side C. Therefore, it will be C squared. Now, which two sides that are forming included angle C? It's B and A. Therefore, you're going to add them, but with the squared. Minus 2, then you multiply these two sides, AB. Cos of angle C. So what you have before the equal sign, after the equal sign, or at the end must be the same. So the opposite side of angle B is side B. Therefore, we put the squared equal to which two sides that are forming angle B, the included angle is A and C. Therefore, you add them with the squared minus 2. Then you multiply these two sides. Cos B. Cos B. I hope that makes sense. I didn't actually hear myself here, but this is correct. All right. if you are given two sides and an included angle, you determine the side of that included angle. You equate it to the sum of these two sides forming that included angle, but you put the squared minus 2 multiplied by the sides of those two. I don't hear myself now. Let me explain it. A squared equal to the opposite side of A. It's A, the small letter A. Then you say A squared equals B squared times C squared. These sides are the sides that are forming angle A. Then you minus 2, you times these two angles, cos A. Let me just do an example. These are sides, right? Now look at this. Let's say we have this side here and included angle. What we're going to do, we're going to multiply. We're going to actually determine the side of that included angle. Then we determine which sides are forming the included angle. Then we add them, and not forgetting the squared, minus 2 times those two sides, cos the included angle. Let's say we have y, x, and z. All right, so this is triangle xyz. We have z here, small letter x and y. Just want to explain that. I feel like I didn't explain it. Okay, now this is an included angle formed by side y and z and x. So the opposite angle, the opposite side of y included angle is that small letter y. Then you put squared. Which two sides are forming included angle y? It's z and x. You put what? The squared when you add them. Then minus 2, you multiply these two sides forming included angle y. Cos what? Included angle y. I hope it makes sense. I hope it makes sense. This is very, very important, guys. Very, very important. Okay, so you will actually try to do these two on your own to see if you understand it, because you need to know this. All right, let's talk about the area rule. I'm not sure if you will see this red triangle on your screen. Well, let me just change it and use the white one. Okay, this is KL, but I think you'll be able to see it. But let's just remove it and use a white colored triangle. Okay. Let's say it's triangle K, L, and M. We have 15 here, or these are examples. We have 25 and we have 30. They want us to determine what the calculates. You see, before you can calculate, you check which rule must I use, or which rule is applicable based on what I'm given. Calculate the size of angle K. So we want the size of angle K, but you can see that here we are having 30, and 30 is the angle, right? Because this is inside, and its opposite side is LK, which is 15, and with another side. Therefore, we can use sine rule. Therefore, sine angle M over small letter m, which is LK, equal to sine K over small letter k, which is LM. Therefore, sine 30 over 15 equal to sine K over 25. Therefore, we cross multiply so that we can make K the subject of the formula. Therefore, sine 30 times 25, it will be 25 sine 30, or you can just punch it in your calculator, equal to 15 sine k. Then you divide both sides by 15. Try to divide both sides by 15. Then the 15 on the right, they cancel out. Therefore, what we have now is I'm trying to punch my calculator right here. So it's sine k equal to 25 sine theta over 15. It's 5/6. Let me try to erase this thing. Okay. Therefore, angle K, we actually try we solve it. Angle K, it's arc sine 5/6. Therefore, you punch your calculator, K equal to arc sine 5/6. What's the answer? It's 56.44. Now let's say they say calculate the size of K, maybe where K or angle K is obtuse. So an obtuse angle, it's actually an angle that is greater than 90 but less than 180. Angle that is less than 180 but greater than 90. And you can see that angle K is an acute. We would actually leave it like that if they said where K is acute, but K now they said is what it's obtuse, meaning we're going to say 180 minus that value of K, 56.44. Therefore 180 minus 56.44, so you can get what? An obtuse angle, an angle that is greater than an angle that is greater than 90 but less than 180, of which is 123.56. But the most important thing here is for you to discover which rule can you use based on the information that you are given. I hope it makes sense. You don't just use a rule because you're you given a triangle. No, you use it based on your understanding. Okay, let's say this is a triangle. Okay, this is triangle. Let me just use a white pen or a white color. Or okay, let's just do it like this. Yes, now we have A, B, and C. Then we have 100 as AC, we have X as BC, and we have 50 as angle A and 55 as angle B. Then they want us to determine the value of X, the unknown variable of X or length BC. Let me erase everything here so we'll be able to see clearly. So you'll try to do that on your own. Then let me draw another one up here. And please don't forget to subscribe to the channel, helping us to actually grow. And don't forget to like the video, share it, hit on the notification bell so you can be notified when we upload new lessons. So we have theta right here, then we have 100, and we have 10 and 20 as km. Then they want us to determine the size of theta. You use the rules, right? This is C, then D. You will do these ones on your own to see if you understand what I was actually explaining. So all right, and we do have classes contact classes whereby you can come to our venue in Foslorus. If you're around in Foslorus, you can come, actually take our numbers in our channel here. It's written, or it is 0678758006 for more information. You can WhatsApp that number 0678758006 for more information regarding our classes when you come to our venue. Or we do have online classes from Monday to Thursday. Okay. These are the sides that you must actually determine, but before determining them, check which rule is applicable so that you can calculate those sides or the angles. Okay, let's try to do this example. ABC is a vertical flagpole. So, AB is a flagpole. Here is our flagpole. That is square root 5p. And if you can actually check this, p is not inside the square root or under the square root, but it is outside, as you can see. Be careful. Meters long. Therefore, AC and AD are two cables anchoring the flagpole, meaning they strengthen the flagpole. So these two are cables anchoring the flagpole. They strengthen the flagpole. And C and D are in the same horizontal plane. Then they're in the same horizontal plane. BD is 2p meters. Angle C equals X and angle D equals 45. Okay, so the entire D here is 45, as you can see. It's not just that 45 is only on the wide triangle, but even the X is also the value of C entirely. It's not like 45 is only this part, but it covers the entire D, the black spot or the gray spot and the white. Then they want us to determine the length of AD in terms of P. The length of AD, this is AD, the hypotenuse. Why? Because ABD is a right angled triangle, as you can see. Therefore, you can use what? Theorem of Pythagoras, because we do have BD and AB. Therefore, let's determine the length of AD. Therefore, AD squared equal to AB squared plus BD squared. And you can write Pythagoras or Pyth. Therefore, we're determining AD. We don't have AD. Therefore, AB, the value of AB is square root, open bracket, square root P. Remember, the P is not under the square root, plus BD, which is 2P. Don't forget the squared. Then we simplify it further. AD squared equal to 5P squared plus 4P squared. Therefore, AD squared equals 9P squared. And they didn't want us to determine AD squared, but they wanted what? They wanted AD. Therefore, what we're going to do? We're going to actually put a square root both sides. Therefore, AD equals 3P. So we solved AD in terms of P. So the length of AD is 3P, and it makes sense. It is the longest side. Okay. That square root 5p is less than 3p, and that 2p is less than 3p, as you can see. So it makes sense that AD is 3p. So we used what? The theorem of Pythagoras. Why? Because our triangle is a right angled triangle. Let's continue. So 7.2. Show that the length of CD is 3p open. This is CD, right? Meaning we'll be dealing with the entire triangle. Therefore, 3p sine x plus cos x over square root 2 sine x. This is CD, the one that they want actually to they want us to determine or to show, to prove. We're actually proving here. So CD, it covers, we can say it's triangle BCD or the entire triangle. But I think we can use the entire triangle because triangle BCD won't favor us, but ACD will help us. So let's see what we can do here. 7.2. 7.2. What we have here, the angle, we don't have angle A, but we have angle D and angle C. Therefore, we can actually add all of them. Angle A plus angle C, angle B, angle D plus angle C, they form 180. Then there is in sum of angles in a triangle. Therefore, we don't have angle A. Let's determine angle A plus D is 45 and C is X equals 180. Therefore, let's transpose everything and make A the subject of the formula. So it's going to be 180 minus 45 minus X. Therefore, A equal to 135 minus X. So this is angle A. We do have angle A. Let me just write it right here. So it's 135 minus X. That's angle A. All right. Then how is it going to help us? Having A, how is that going to help us? Now, what we see is that in triangle ACD, we now have 45, we have X, and we have 135 minus X as the angles inside the triangle. So these are interior angles. I hope that makes sense. Therefore, we can use the sine rule, because we do have the properties of sine rule here. So sine A over CD equal to sine X, or let's just say we have sine C over its opposite side, which is AD. It's all about understanding the rules of the properties, when to use them. Therefore, sine A is 135 minus X over CD. We do have CD, it is, or we don't have CD, we must prove it. So sine C is X. So sine X over AD. What is the value of AD? Is 3p. We have 3p. Then we can actually cross multiply. We cross multiply sine 135 minus X and 3p and sine X and CD. Okay, let's see what we're going to have. But I hope you understand why I use sine rule, because we have angles and their opposite sides. Okay, so, CD sine X equals 3p open bracket sine. Why am I actually writing 3p inside here? Because it must be sine 135 minus X close bracket. Therefore, let's make CD the subject of the formula. We're going to divide both sides by sine X. So that CD will be the subject of the formula. Okay, these ones, they cancel. Therefore, we are left with CD that's equal to 3p. Sorry, 3p open bracket sine 135 minus X and close bracket over sine X. This is our sine D, but we have to simplify it further, because it's not one the same thing as what they want us to prove or show, right? Now we can actually continue from here, so that it can be the same as what they want us to show, using what is known as compound angles. So we can use compound angles to simplify sine 135 minus X. Compound angles. So if you're in grade 11, this is grade 12. You can use compound angles here. And you don't have compound angles, maybe in grade 11, I don't remember. Okay. So, let's see what we actually talking about. We have the compound angles of cos and compound angles of sine. So as a grade 12 learner, you know this, so I won't explain it further. We'll just write the compound angles. So CD equal to 3p, open bracket, sine 135 cos x minus cos 135 sine x. These are compound angles of sine. Then close bracket over sine x. Therefore, we can actually simplify further, reduce sine 135 and cos 135 using reduction formulae. So sine 135, it will be sine 180 minus 45. Then it gives us what? Positive sine 45, which is 1 over root 2 if you're using special angles. Cos, then it will be negative cos 45 too, because sine 45, sine 135 and cos 135, they give us the same answer, over sine x. Therefore CD CD equal to 3p, open bracket. We do have sine 45 as 1 over root 2 when you use special angles, cos x minus 1 over root 2 sine x, then all over sine x. Therefore CD equals 3p, open bracket, root 2, it's cos x minus sine x. So 1 over root 2 is what? Is a common factor. Then this is what? This is our CD, but we do have to simplify it further. We don't want too much brackets. Okay. We're going to multiply the 3p and 1 over root 2. Therefore, it's going to be 3p over root 2 times cos x minus sine x, close bracket, over sine x. Okay. We can reciprocate sine x. Therefore, it will be CD equal to 3p over root 2 cos x minus sine x. I hope you're still following. Cos x minus sine x times 1 over sine x. Then we multiply them. We're going to have what? 3p times cos x minus sine x times 1. It will be 3p cos x minus sine x over root 2 sine x over root 2 times sine x, which is root 2 sine x. So this is our CD. Now let's check if they correspond with what is written on the question. Let me just try to erase. So here we're having a positive, and what actually solved, we are having a negative. This is what they want us to prove. What did we have? Why did I get a negative? Oh, I see the mistake. I see the mistake now, but let me show you the mistake. Okay. What made me to have a negative sign? I'm going to fix it right now. I'm not going to start it afresh. Just going to check the sign there. Look at this. After getting the answer of cos 45, it will be cos 180 minus 45. The answer will be negative, and negative times that negative is going to give us a positive, right? Therefore, that's why I'm changing these signs to be positive. I hope that makes sense. This is what I was saying. If we determine cos 45, it will be, cos 135, it will be cos 180 minus 45. And the answer here is going to be negative cos 45. Therefore, the negative cos 45 times the negative on the original equation there, they will be positive. So I forgot to actually show that, but I hope you understand this. It's very, very important. You see, mistakes happen, so make sure that you double check. So that is the value of CD. Okay, well, let me just try to restore the information, but you understand it. I can see that you really understand it. Let me restore this information. So, but the most important thing is for you to know how to use the rules, right? That's very, very important. Very, very important. Please do help us to grow Maths and Science series by subscribing to the channel and hit on the notification bell. Okay, they want us, it is further given that P equals 10 and X 110. Calculate the area of triangle ADC. So we are given the area. They want us to determine the area. We're given all these other values or sides, angles to determine the area of triangle ADC. So we have 3p here as 3cd as 3p open bracket sine x plus cos x over root 2 sine x. So root 2, yes, sine x. I'm not sure if you're going to have space here to write all of this, but I'll make it plain. CD times AD. I doubt. Let me remove it. Okay, so half, but let's try it. Half times CD times AD. Why? Because these they form angle D. So CD and AB are side forming included angle D, which is 45. Therefore, half times CD, which is 3p, we have 10, and sine x, we have 110 as x, plus cos 110. Now, we're not going to have space because we have to continue writing the size of AD and angle D. So this is just CD only multiplied by half. Let me just erase it and try to make us a space. Okay. I thought that I would actually move the screen to the right, shift it to the right, but I couldn't. That's what translation along the X. Yeah. Okay, 7.3. These two sides are forming included angle D, as I've explained. So it will be half times CD times AD sine included angle D, because CD and AD they form included angle D, as you know. Therefore area yeah, I doubt that we're going to have a space here, but I think I'll write it the size of CD with all the substitution on the other side. Okay, but we'll see what to do. So it's going to be half times, let me just write it on the, remember this is CD, let me just write it up here on the paper of the question, so that we'll have space. Because if I would actually take that to this black background here, it will never have space. So 10 times sine 110, 110 here, plus cos 110, then we close the bracket, all over root 2 sine 110. Then I'll actually punch it in a calculator and put it as the size of CD, but make sure that you actually write everything in your book, your substitution. They must actually see it. Okay, so let me try to use my calculator. 3 times 10, open bracket, sine 110 plus cos 110, close bracket, over square root 2 sine 110. This calculator is giving me problems. Let me just try it again. Okay, I got 13.49. I'm not sure if rounding off will affect everything, but we'll see. We do have P as what? As 10. Therefore, sine 45. Sine 45. Then let's actually multiply everything so that we have the area of triangle ACD or ADC. You can also try to use your calculator, but I doubt it will give us the correct answer because we rounded off CD before the last step. But let's just try our best. But make sure that you do not round it off before the last answer. So it gave me 143.08. Then you write meters squared because this is the area, or units squared. Well, let me just try to write everything here without rounding off, so see if the answer will be actually corresponding or will be the same. Let me just write it down here, but meaning I will compress the numbers so that we'll have space. Doing the same thing, half, let me just write, or half area equal to half CD. We do have CD, it will be 3 into 10, open bracket, sine into 110, close bracket, plus cos 110, then we close the bracket, over root 2 sine 110 times sine 45. I had to actually compress the way the numbers. Let me punch it in my calculator. I think we're going to have the same answer but different decimals. Why? Because I rounded it off up there before the last answer or the last step. So I think this one is the one that is going to give us the correct answer, because we didn't actually round off anything here. So rounding off before the last step affects the final answer. So the area is 143.11. You see the answer is the same, but the decimals differ. Why? Because I rounded it off before the last step. So I think do not round off before the last step, right? Okay, so this is our answer. This is our answer. So make sure that you understand everything. Sorry. All right, it's all about understanding the rules and how to apply them. That's very important. So here's our question. This is question 7. So in the diagram, S, T, and K lie in the same horizontal plane. RS is a vertical pole. So is RSD, RS a vertical pole. Therefore, the angle of depression from R to K is beta. So beta right here is the angle of depression. And let me just explain something about this angle of depression. Let's say we have an angle here, theta. Then theta is known as the angle of depression. And what you must know, it is equal to the angle inside here. I hope that makes sense. Meaning angle beta, since it is what it is, a depression, angle of depression, it is equal to K. I hope it makes sense. So there's a mark for that. Determine the length of SK in terms of P, Q, and A. We can see that SK is also in this right angle triangle because we cannot use it. Why? Because we don't have the size of RS and RK. But we can use this one. Why? Because we have its area. We have one side which is ST. I hope it makes sense. We do have the area of triangle STK. Therefore, I think we can use it. We can use the sine rule. I'm not sure if you understand why I'm saying we can use the sine rule. It's because we have two sides, which is TP and SK, the one that they want us to determine, plus the area. I hope it makes sense. Therefore, the area of triangle STK, let me just write it like that. The area of triangle STK equal to half times TS multiplied by SK. They form included angle. S. No, we cannot say S. Why? Because it is not the entire S, but it's just A. Let me just put A and remove angle S and put A. I hope you understand this. Why we're using area formula? It's because we have two sides and the included angle. The two sides that we're having is that one that they wanted to determine. Plus, we do have the area. So half multiplied by TS. TS is P. Then SK, it's SK times sine alpha, not sine alpha, but sine A. Then they want us to make what SK the subject of the formula. Therefore, we're going to divide everything by half P sine A to make SK the subject of the formula. Let me just make myself a space here so that we'll be able to divide both sides clearly. Okay. This one won't really help us to run the same thing. Let me just pull it to the right a bit. So half P times SK sine A. Then we divide both sides by half sine to make SK the subject of the formula. So it will be half P times sine alpha or sine A. What you do on the left, also do that on the right. They were busy telling us in primary school, I think in grade 4. So these they cancel. Then we are left with SK on the right. Therefore, Q over half times P sine alpha equal to SK. I don't know why I keep saying sine alpha. That's A, not alpha. Therefore, we can actually simplify it further. We can simplify the denominators on the left. Now, let's see how you're going to do it. Q over, it's over 1 here. Then we can multiply it's P sine alpha over 2 multiplied by, equals SK. Therefore, Let's reciprocate the denominator. So q times 2 over p sine A equal to sk. Therefore, 2q over p sine A equal to sk. So this is sk in terms of pq and A. Let me just write it here. sk. Where's sk? Okay, in triangle STK. This is how you solve it. We use the area rule. Why? Because we have these two sides and the included angle and the area of that triangle. So let me try to write the size of SK so that I'll be able to erase this and create as a space. So the size of SK here is 2q over p sine A. I hope you understood it. They want us to show that RS equals 2q tan B over p sine A, 7.2. What we know here is that the angle of depression equals K in triangle RKS. So there's a mark for that. You have one mark. If you're satisfied with that one mark, you can actually leave it like that. So RKS equals what? Angle K there equals beta. It is equal to the angle of depression. There's a mark for that. Therefore, what relationship does angle B or beta and angle what relationship does it have with RS and SR? That's the question that you must actually ask yourself. Why? Because you do have SK and they want you to find RS, or to show that RS equals that. What am I saying? What I'm saying is, let me just make this a quick example. Let's say we have beta here and we do have 2q over p sine alpha as the adjacent, and they want us to find the value of y. What relationship does B have in y and 2qp sine A? That's the question that you must actually ask yourself. It must actually give us the trig ratios. Okay, we have theta and we have, let's say we have 30. We have 30, we have 7, and we have y. What relationship does 30 have when you talk about y and 7? It is what? It is tan. So it will be tan 30 equals y over 7. Then you do what? You cross multiply and solve the value of y. That's what we are having here, because we have sk and they want to determine what? RS, and we do have the value of k in triangle RKS. So the relationship that it has, it should be tan. The relationship that beta have when we talk about RS and SK, it should be tan B equal to RS over SK. Then let's do the substitution. So tan B equal to RS over SK. The value of SK we know is 2q over p sine A. Therefore, tan beta equal to, we reciprocate the denominator, ks times p sine alpha, not sine alpha, sine A over 2q. Then over one side we can deal with fractions both sides. Therefore, what we're going to do right now, we're going to say tan B equal to rs times p sine alpha, which is rs p sine alpha over 2q. Therefore, we cross multiply so you can make rs the subject of the formula. So it's going to be 2q tan b equal to rs p sine alpha. Then let's make rs the subject of the formula by dividing by p sine alpha both sides. Then they cancel. Then what we have now is rs being equal to 2q tan beta over p sine alpha, of which is what they wanted us to show. I hope it makes sense. So you just need to understand your diagram and try to interpret it. Okay, so 7.3, they want us to calculate the size of A if A is less than 90. When they say A is less than 90, it means that A is an acute angle. I hope that makes sense. Let's try to solve let's try to solve 7.3. They want us to solve the size of theta. Theta is an angle. Okay. 7.3. We can use the very same RS. Let me just try to see what we are given and what RS has. Yes, I think we can really use the very same RS. Why? Because we do have RS, P, we do have what? Q and beta. Therefore, we can use it. Therefore, RS equal to 2Q tan B over P sine A. Therefore, RS is 70 and Q is 80. Tan B, the B is 42. Then Q must be 2500, not 80. It's 2500. Sorry about that. Over P. That P is 80. Yes. Sine alpha. Therefore, we can cross multiply. Therefore, 70 times 80 sine alpha. That's what we're going to do right now. Or you can actually write everything up there as numbers from your calculator. So 70 times 80 sine alpha, 5600 sine alpha equal to 2 into 500 tan 42. We divide both sides by 5600. These ones they cancel out. Therefore, sine alpha equal to 2 into 500 tan 42 over 5600. And check. It's okay. Sine A equals sine arc sine 2 into 2500. 2 into 2500, not just 500. I made a mistake up there, so put these 2 to be 2500. So 2 into 2500 tan 42 over 5600 equal to, then you put what? Actually, this arc sine, the brackets covers the entire fraction. Therefore, I'm going to put the square bracket or the bigger bracket, not just on the numerator, but that covers numerator and the denominator. I hope that makes sense. So it's going to be a square bracket covering the entire fraction. I'm trying to punch it in my calculator. So here's the square bracket covering the entire fraction. Then let me try to punch in my calculator. It gave me 3.51. So this is the size of angle A or angle alpha. Actually, I can't say angle alpha because that's A. So that's it. That is the size of A, and A is less than 90, as you can see.